In this video, we will do an example on basketball win probabilities. So the example says Alabama, Baylor, Cal, and Duke are in the Final Four. So the Final Four is just a name for the last four teams that are still in a college basketball tournament. Suppose Alabama is twice as likely to win as Baylor, but half as likely as Cal, which itself is 3 times as likely as Duke to win. What's the probability that Cal wins? So if we think about this question and how it's different from other examples we've done so far, we might notice that this question doesn't tell us any probabilities straight up. Instead, it just tells us how likely teams are to win compared to other teams. So because I don't have specific numbers like that, I'm probably going to need to assign a variable. So let's pick one of the probabilities, like maybe I'll talk about the probability that A or Alabama wins. Let's call this X. So I'm going to let this be the probability that Alabama wins. So then, based off of what's given to us in the problem, let's try to write down some equations. So for example, the problem says that Alabama is twice as likely to win as Baylor. How would I write that down with an equation? Well, that would be saying that P of A, the probability that Alabama wins, is twice as much as the probability of Baylor winning. So this is going to be equal to 2 times the probability that Baylor wins. All right, and for probability of A, we call that X. So we have X equals 2 times the probability of Baylor winning. And we could isolate this for P of B. That's why I'm putting an implication arrow. So P of B, if I divide by 2, is equal to X over 2. Alrighty, so now let's see if we can set up another equation. So the next part of what that sentence says is, suppose Alabama, well, it said they're twice as likely to win as Baylor, but half as likely as Cal. So Alabama is half as likely to win as Cal. All right, so okay, let me put the first one in yellow. Alabama winning, that probability is twice as likely to win as Baylor. That was this. And now let's do the one that says Alabama's half as likely as Cal. So the probability of A is going to be equal to 1/2 of the probability of Cal winning. So that is my equation here. Let's highlight that in blue. Okay, and the probability of A winning, we said was X. So we have X equals 1/2 times the probability of Cal winning. And I can multiply both sides by 2 to get rid of that 1/2. And that would give me the probability of C winning is 2X. So nice. So there's one more of these equations I can set up. So the last piece of information I can convert to an equation is, so when it says that sentence, Alabama is twice as likely to win as Baylor, but half as likely as Cal, then it follows that up by saying, which itself is 3 times as likely as Duke to win. So the which itself is referring to the last team that was mentioned. So Cal itself is 3 times as likely as Duke to win. Okay. So at this point, pause the video for, this might take 30 to 45 seconds to see if you can set up an equation for that last piece of information. So I'm going to highlight this. So Cal itself is 3 times as likely as Duke to win. So 4, 3, 2, 1, pause that video. Pause it for 30 to 45 seconds to see if you can set up this equation on your own. All right, so hopefully you did that. Hopefully you paused the video and at least tried it and made an attempt at what this equation is. So this is saying Cal is 3 times as likely as Duke to win. Okay, so the probability of Cal winning is 3 times the probability that Duke wins. So 3 times P of D. And with this, let's see, probability of Cal winning, we just said was 2X. And let me highlight this in green. The probability of Cal winning was 2X. So I'll write that here. Equals 3 times P of D. And if I isolate P of D, I'm putting an implication arrow, and I divide both sides by 3, this equals 2x over 3. Okay, so now I at least have each of these probabilities, that A wins, B wins, C wins, D wins, in terms of a variable. So we know that when we add all of these different cases together, probability of A winning plus the probability of B winning plus the probability of C winning plus the probability of D winning, because those are all the different scenarios that we might have here, these should add up to 1. So if I plug in each probability, this is x plus x over 2 plus 2x plus 2x over 3 equals 1. And now let's solve this equation, which I'll do on the next page. So here is our equation. So there are a couple ways we could go about solving this equation. We could either get a common denominator because we have fractions that we're adding that have different denominators, or I could decide to multiply both sides of the equation. I'm just going to EQN and abbreviate equation, multiply both sides of the equation by something that would get rid of all of the denominators. So to get rid of this 2 in the denominator, I would need to multiply both sides by 2. But to get rid of that 3 that's in this other denominator, I would also need to multiply both sides by 3. So let's multiply both sides by both 2 and 3. In other words, I'm going to end up multiplying by 2 times 3, which is 6. We're doing that to get rid of the denominators, but we could also do this by getting a common denominator if we preferred. Okay, so let's copy down the equation. X plus x over 2 plus 2x plus 2x over 3 equals 1, and I'm going to multiply this side by 6. And whatever I do to one side of the equation, I got to do to the other side. And now the 6 is going to distribute to each of these terms. So we'll get 6 times that x, and then plus 6 times x over 2, and then 6 times 2x is 12x, and then finally we'll get 6 times 2x over 3, and then that equals 1 times 6, which is 6. All right, now let's simplify. So this 6 and that 2 can cancel. I can divide each by 2 to be left with 3 here and a 1 there. And then this 6 and this 3 can cancel a little bit. I can divide both by 3 to get 2 left here and 1 left there. So that gives us 6x plus 3x plus 12x plus 2x. Or sorry, no, this is going to be, I have 2 times 2x, which is 4x equals 6. And if I add these together, 6x plus 3x plus 12x plus 4x, we get 25x equals 6. And if I divide both sides by 25, we get x equals 6 over 25. So I got to make sure I answer what the question wanted. And it wanted the probability that Cal wins. So we want to find P of C, probability that Cal wins. And looking back to the previous page, the probability that Cal wins is 2x. So I need to work out what 2x is. So P of C is equal to 2x. So 2 times 6 over 25. So if you multiply a fraction by a whole number like this, the 2 just multiplies the numerator. So this gives us 12 on the top, 25 on the bottom. Another way to see that is, I can think of the 2 as a fraction as being 2 over 1. And then if I multiply that by 6 over 25, then when I multiply two fractions, I multiply their numerators together to get 12. And multiply their denominators together, and 1 times 25 is 25. So we get 12 over 25, and that is our probability. And I'll leave this as a fraction. All right, so in terms of our goals for this section, we finished our last goal, which is we've worked out some examples in which we've computed probabilities using both set and counting techniques. So in our next section, we're going to continue talking about probabilities, but we'll look at situations where we need to use permutations or combinations or different counting techniques to work out the number of outcomes.